Welcome to the on-demand broadcast of Smart CSO, how digitalization can improve sewer network management. My name is TJ Willits from Veolia Water Technologies, and I'll be your moderator for today's on-demand event. Just want to let you know that this webinar is part of our Veolia Water Tech Talk series, but we're doing a special focus in May for the digital transformation for wastewater and sewer utilities. You can see that today we're going to be discussing Smart CSO, but we have some webinars on demand available at our website there. So you can log on to our website, veoliawatertechtalk.com, and view those on-demand webinars to get caught up on some of the other topics that we discuss related to digitalization. Also, we have some upcoming webinars scheduled for Wednesday. And our on-demand webinar is scheduled for Wednesday, June 6th. Next month, we have a webinar on managing peak weather flows. That could be an interesting companion to what we're going to discuss today. Also, we have a webinar scheduled for Thursday, June 17th, and it's about mobile water services. And it's about how to ensure continuity with reliable mobile water solutions as a backup plan. So if you want to tune in for those live webinars, just go ahead and sign up at veoliawatertech.com. And again, there's our website where we have all of our content and our on-demand webinar listed. So go ahead and log on there, and you can just sign up to watch any of our content on demand. And for participation certificates, if you watch today's broadcast and you would like to request an on-demand participation certificate, you can do so by just sending an email to water.info@veolia.com, and we'll send a certificate back to you so you could use those for continuing education credits. And for those that may be new to learning a little bit about Veolia Water Technologies, we're a global leader in water and wastewater management, and we provide our customers a variety of key pillars and services. So we have a lot of technologies within our portfolio that we can employ. We service those technologies with everything from digital services to mobile water services, aftermarket services. And then we also could take in multiple technologies and pair them together to put a comprehensive EP project together for our clients as well. And on the next slide, you'll see that we service customers from every single market segment, industrial, municipal. We provide all of those technologies and services to our clients. So we work with a lot and have experience from all these industries listed here. And now we're going to transition to the technical portion of today's presentation, Smart CSO, how digitalization can improve sewer network management. We're fortunate to have two expert panelists with us today. The first that you'll be hearing from is Mark Drake. He's a service and digital programs manager with Veolia. He's been a water professional for over 20 years and has his undergrad in chemical engineering with an environmental emphasis from Iowa State University. Mark has held a PE designations in Wisconsin, North Carolina, and became lead accredited professional in 2008. He's been part of the Veolia team since 2010, where he currently serves as the service programs manager and product champion for the Hubgrade line of digital solutions. Mark is also very active in the NCAWWA, serving on and previously leading the wastewater operations school committee, and also teaching several classes for treatment facility operator certification. Joining us as well for today's Chris Next. She's a digital sales for urban water. Kirsten works with the digital suite of products for anything urban water related. She has her master's in environmental engineering from the Technical University of Denmark, with also a semester spent at Clarkson University in New York. She wrote her master's thesis with Water Software Development Company, researching algorithms for model predictive control for sewer systems. And since she's been with Veolia, she's been working as a modeler with hydraulic engineering, focusing on optimal use of the urban drainage system. So in addition to all of her work that she does here with Veolia, she also takes time to teach classes on climate adaptation at the Technical University of Denmark as well. So at this time, I'd like to hand the presentation over to our first panelist, Mark Drake. Mark Drake, are you with us?
I am here.
Great, thanks.
Okay, so we have a pretty ambitious agenda today, and hopefully we get through it without having to speak too quickly. I'm going to address an introduction with some discussion of some key challenges many of you are going to be familiar with, and we'll talk about the types of digital solutions we have available to address those challenges. From there, I will go ahead and hand it over to Kirsten, who is certainly the more technically adept person when it comes to the digital services that we're able to provide to meet the challenges. She'll go through the functionalities, talk about how the digital technology makes decisions and controls sewer systems, and we'll go through some case studies and talk a little bit about how we approach projects and how we approach putting together the right solution for our customers. So to start off with, as I said, I think most people, if you're here in this webinar and viewing the content we have for you today, you're probably aware of at least some of the challenges that collection system operators, municipalities, and those who are stewards over that infrastructure face. Much of that is driven by rainflow events. A lot of that is driven by CSO events and the impacts that has on our lakes, our rivers, our estuaries. But even facilities or even communities that aren't CSO communities, when we have wet weather events, we have infiltration, we have inflow, we have impacts in sanitary sewers, and certainly impacts at our wastewater treatment facilities. There are lots of challenges that come from dealing with this water, dealing with how we manage our collection systems to help protect our lakes and our rivers and our estuaries. Just to put some numbers on some of the problems that are associated with the challenges we face. Just last year, in the first 9 months of the year, the state of Michigan, which does have a number of CSOs here in the CSO communities here in the U.S., they had beaches closed by pathogens more than 100 times within those first 9 months of the year. Up in Canada, there's a large volume of untreated CSO releases every year. You can see the number there in 2017. So there are many ways to address these types of infrastructure challenges. Let's go ahead to the next slide. And a key question for us, in which many of you probably have, is can data-driven decision-making be part of that solution? Are there real-time decision-making, data-driven responses, things that we can do that aren't physical infrastructure that can help us better manage in dealing with both the direct challenges that we see in our collection systems and indirect challenges to implement those kind of solutions. So that's going to be a key focus today, is how can we utilize data-driven solutions to address these kind of challenges. And at Veolia Water Technologies, we have a whole suite of digital solutions that fit within a brand name that's called Hubgrade. That spans a very broad range, from collection systems to wastewater treatment plants, to specific pieces of equipment, to complete fully integrated facilities and complete management of systems with multiple wastewater treatment facilities. At its heart, it is utilizing various forms of data that come in from sensors and other areas to allow us to better operate the systems and equipment that we manage. So Hubgrade is a very broad solution. Today, we're really focused on the types of solutions that we implement in collection systems. to help address those challenges of CSOs and SSOs and impacts on our receiving streams. And what Kirsten is going to really get into some detail on and share some case studies on has to do with some of the latest model predictive control, but also talking about some other, more simple steps and things that can be done that don't necessarily go quite that far, and talk about how we bring those solutions together and bring those to our collection system managers to help them deal with those challenges and better operate their collection systems. So with that, Kirsten, I will hand that over to you to get into a bit more detail.
Thank you, Mark. Okay, so I'm here to talk about the technology. And before I get into all the control algorithms and all the things we can do, I want to take a step back to look at in Hubgrade, which Mark just presented, our tool called SewerView cannot be used on many levels. And the most simple is just for visualizing what's happening in your system right now, which a lot of the time can be a really great asset to get an overview of your system. So this is a place where you can get real-time alerts for abnormal situations. It's a place where you can have overflow data easily available to create reports. And it's this visual, real-time or historical presentation of basin filling, rainfall, pumping rates, basically anything going on in your system. This is step one to the digitalization. So the functionalities of this tool is things such as warnings about what's happening in your system. If you have a blockage, for example, it can be getting alarms when you have a CSO occurring, whether the alarm is on your phone or an email. It can be alarm systems for recreational waters. So imagining billboards on a beach or something like this, where you want alarms in certain, for example, CSO situations. It can be where you visualized your radar rain forecast to see what's happening in a few hours to your system. It's a place for inflow and infiltration analysis. It's a place for forecasting inflow to your treatment plant or for any other point of interest. It's a place for overflow statistics and for just storing and visualizing any data you have from measurements campaign to keep it all in one place. So I want to just give you a quick look, see what it is. This is from a town that has implemented SewerView on the entire catchment and on the treatment plant. So if you log on as an operator, this is what you're going to see. So you log on and you see in real time what's happening in the system right now. So you have your basins and you see how full they are. You have your pumps, you see whether they're on or off right now. Your gates, whether they're open or closed, how full are your different pipes. You see your rain gauges, what's been the amount of rain today. You can even see the radar forecast for specific locations, what's going to happen within the next couple of hours. So this is the overview of here and now, what's going on. Then if you want to go further into detail, like I've zoomed in here on a basin, and we see that this basin has a capacity of 2,592 cubic meters. And at the moment where I took this screenshot, it was 34% full. And then you can go look at a graph real quick and just see, okay, over the last couple of days, how full has it been? What has been happening at this location? We see here the filling degree, and we see that there's been no overflow. But you can also go more into detail when you go away from just real-time visualization, but where you go into the historical data. And this is where you can really start to understand your system, because then you can jump into looking at the rain gauge right by your basin to see what's been the rain. This is what we see on the top. And on the bottom, we see the inflow to the basin. Then you can start comparing, okay, what's happening at different types of rain events. We can compare it to, here we have the overflow. So you can start getting an understanding of what's happening in your system when, and the different dynamics. If you want more of an overview of everything happening in your system, this is an overview of CSOs. So I've just plugged in specific dates for a period in time where I would like to know how much CSO did I have in different locations. So the orange dots are where I've had CSOs and the total volume in this period. And you also see how much rain I've had in different locations at the same time. So this gives you kind of the spatial overview, but you can also get it as a report, which you might need for authorities or other types of reporting, where for whichever period you're interested in, you get to see the sum up of your rain gauges and all your CSO locations. How many overflows did I have? What was the duration? And what was the total volume of overflows? This is also great when you want to start prioritizing where in your system are you going to make changes. You want to make them in the places where you get the largest benefit, right? So moving on from just looking at data and understanding your system to actual data-driven decision making. Some of the things we offer are things such as I&I analysis, which is very relevant no matter if you have a separate or combined sewer system. We see a lot of I&I, and you want to look into why it's there and where it's occurring, so that you can prioritize your renovation. And with the digital solution, you have your data coming in all the time and your I&I updated automatically without any engineers having to do the calculations. You can also use all this data available for an inflow forecast. So you know at your treatment plant how much water is going to be coming in a couple of hours, thereby having a chance to prepare and increase your hydraulic capacity. Or it could be things such as using your overflow statistics for prioritizing your future work. Now, if we then move on to actually controlling the sewer system through Hubgrade, there can be many reasons for controlling your sewer system, and we have a whole range of possibilities for how to do the control depending on what your wishes are, what it is you wish to achieve with this control. Of course, a lot of the time a control will be implemented to reduce the CSOs. But what you can also do is prioritize between the CSO locations. If you have one place you prefer having the CSO over another place, it can be a great alternative to constructing basins. So this is where we see it being really useful when you're about to go with the traditional approach of just building more concrete. You can really reduce your CAPEX and your CO2 emissions if you use control instead of construction. You can also use control to control the inflow to the treatment plant, which is very much preferred by plant operators to get a nice, smooth, even inflow to the plant. Or you can control your system so that you're using your pumps when you have low energy prices or when you have green energy, if that's varying. So which approach you choose for your control has to depend on what your local priorities are, what it is you wish to achieve, and what your available infrastructure is, of course. So what you want to consider when you have your own local situation is, okay, what is the purpose of my control? What is it I want to achieve? You want to think about how big the system is. If you have a small system or just a small local catchment, you can oftentimes achieve a lot just with a simple, for example, rule-based control. But if you have a big system, then you might want to go to the more complex model predictive algorithm-based control. It's important whether you have a separate or combined system. There's good solutions for both types of systems, but it is different things you want to look at. It's relevant whether you have some controllable devices in your system. This could just be a pump, or it could be a gate or a movable weir. And also if you have any sensors in your system. When you want to start controlling, it's very helpful to always get updates on what's actually being measured in the system right now, so we're not only predicting the future. And then you might want to think about if you are ready for the whole package, if you want to go ahead and implement a global control on your entire system, or if you maybe want to start with just the sewer view, the visualization of the dynamics in your system, or a simple forecast to kind of familiarize more with the digitalization, and then you can move your way up once you start getting an overview of whether your system is even being fully utilized the way it is today. So to go a bit more into the control, there's the three main objectives for control. There's controlling the inflow to the treatment plant, and you do this to reduce your bypass and to reduce your OPEX at the treatment plant from getting just an even inflow. Then there's the control for controlling overflows in the system. This can be for environmental reasons or because you would otherwise have to build new infrastructure, so you want to reduce your CAPEX and your CO2 emissions. And then there's the control based on electricity prices. So of course you can go with the simple rule-based control that you're probably familiar with, kind of an if-else statement for if you just have a few local basins. Or what we also use a lot is this model predictive control, where what you need to have is a weather forecast. So it can be a radar or an NVP, anything really telling you in a couple of hours how much rain are we expecting. And we combine this with a simple model of the system, and then with live measurements from the system to always bring in a filter to always update our model with what is reality right now. This is all entered into our optimization algorithm, where we find the optimal set points. And this is based on your priorities. So this is where it's important to have decided whether you want to reduce CSOs or you want to control your inflow or what the purpose is. Then this optimization algorithm will find the optimal set points for your controllable devices. And then from Hubgrade, these set points are communicated through a SCADA system or to the local PLC to control pumps or gates or whatever you have in your system that's controllable. So I'm just going to go through a few case studies with different methods of control that have been implemented. They're all located in Denmark, where I am also currently. We have a case study in Kolding, then we have one in Roskilde, and then we have one right near Copenhagen. So the first one here is at one of the major treatment plants of Copenhagen, the capital of Denmark. So they had a wish for an inflow forecast to the treatment plant. They had what's called a stormwater mode at the treatment plant, so they were able to increase the hydraulic capacity to handle larger amounts of rainwater in the system, but they needed a warning of 1 or 2 hours. So the solution for us was to combine the radar forecast with just a simple lumped model of the catchment. And using this, we were able to predict the inflow to the treatment plant. So what they achieved from this was increasing the hydraulic capacity, and thereby they reduced both the bypass at the treatment plant and avoided sludge escape. So no new infrastructure had to be built. It was all through the digital solution. And this was a project that was done in only 2 months. And I just brought a little graph for you. This is from the actual flow forecast. So what you see here, the blue line is the measured inflow to the treatment plant. And then we did the forecast with 2 different weather predictions. The black line is the radar forecast, which is typically more exact, but only with a 2-hour horizon. And the green line is the weather model, which has a longer prediction horizon, but is more uncertain. So you see what was predicted, what was actually measured, and that especially the radar forecast fit very well. And then you see it predicting 6 hours into the future with a band of uncertainty, so that it was also possible for the treatment plant operators to decide whether to trust the forecast or not. A case study of just a small local rule-based control in a town outside of Copenhagen. So the issue here was that the municipality was having too much CSO at a specific location, and they were about to go and build a new basin, a really big basin. And the solution turned out to be combining the construction of a new basin with a rule-based control, where we just controlled a couple of basins nearby, and this allowed us to build a much smaller basin. So we carried out a study of the utilization of the existing basins, and we found out that they were not being utilized at all, that we were having CSO occur before both basins were full. So by just implementing through Hubgrade a simple rule-based control, we were able to meet the environmental regulations by reducing the CSO, and also have significant savings on the construction because a much smaller basin was necessary. Again, this was a 2-month analysis of the catchment and basin with this analysis and definition of control rules to be implemented. Now on to a slightly longer case study of Kolding, also located in Denmark. They have gone through quite the digital transformation. In 2007, they got real-time control at their treatment plant. And then in 2011, they decided to also introduce real-time control in their collection system. And as you can see on the slide, they had 41 pumping stations, they had 23 storage basins and 90 CSO locations. So we had a lot of volume to work with and a lot of locations to control. But first off, they started with a control that was just real time with no predictive element, no weather forecast. Then we moved on to add more elements to get a better performance of this control. So what the algorithm is looking at is both the current basin filling, the current volumes in the system. It's forecasting how much runoff are we expecting to each controllable location. We have the capacities of gravity and the pump basins discharge rates. And we also, at any time, are looking at the treatment plant. So this is an integrated control, controlling the sewer system and the treatment plant together. So the sewer system is at any time looking at the treatment plant and seeing what is the current hydraulic capacity. And then the last thing is that it's also looking at the relative cost of overflow events. So what this means is that the utility has prioritized and said we have specific locations where we would rather have overflow than other locations, and so the algorithm prioritizes where to have the overflows, and that if you already have overflows occurring in one location, then it's preferred to keep having overflows here instead of having overflows in all of your locations. This was important to this specific municipality. So the conclusion on this case story is they needed to reduce their CSOs, and to begin with, they had a decent amount of storage volume, but if they wanted to get from these 30 to 35 overflows per year down to less than 10, as was required by the government, if they wanted to go with just physical structures, they needed to scale up to more than 1.3 million gallons of retention volume. But instead, they created this option of going up to just 500,000 gallons of retention volume, but also adding this CSO, the digital control algorithm, and choosing this solution, which required much less retention volume, actually saved them $2.4 million because they chose this digital approach. And I want to let you know that included in this price was the control algorithm, was sensors and controllable gates and everything they needed. So there was really money and concrete to be saved here. So if this is something that's interesting to you, and I hope it is to most municipalities and utility companies, there are several ways to approach this digital journey, and it's very different where the individual community is. Of course, you can jump right to the big optimization algorithm, global control. But what you can also do for starting this digital journey is to just start with the system overview, what I presented as Sewerview. So you start familiarizing yourself with the system dynamics, you start identifying where the issues are, and you start understanding whether you're actually utilizing your full volume. Once you have all your data here and you've started to see it in real time, then it's very easy for us to map the control of potential. So before implementing it, to do an analysis and say, okay, how much potential is there actually in your system? How much could it help you? And which kind of control could we recommend when also being familiar with your priorities? And then it's easy from there to go on through Hubgrade and integrate either a local rule-based control, if this is what makes sense in your catchment, or the global predictive control with the weather forecast. So to get started on this, I just want to make it clear to any of you who are already familiar with Hubgrade Performance Plan that Sewerview and the control algorithms are just another part of it, the same website, same platform and everything. And for every additional control feature or analysis you're interested in, it's just another module that you add on. To get started with this, all you need is sensors in your system or even just a pump that's reporting how much it's pumping. You only need one sensor to get started. That's how little you could do with. And with that, you'll have real-time analysis, and you'll always have these reports available. And to get this real-time data, you can connect through APIs, FTP servers with an OPC bridge to your SCADA system, or whatever is possible for you. And yeah, I think all I need to say now is you're always very welcome to reach out and let us know about what challenges you have in your system, what's interesting to you. In the US, it's Mark, and in Canada, it's Martin. And I think I'll hand the word back over to TJ. I don't know if you have any closing remarks.
Yeah, thank you so much, Kirsten, for sharing all of your expertise. Thank you to Mark as well, who presented. We did get a couple questions before the webinar that I figured would be great to share for this on-demand recording. So hopefully you don't mind answering them. But a question that was sent in prior to the webinar was, how many points of interest or sensors do you need in your system to get started on the digital journey? Is there a certain sweet spot or a certain minimum to get started?
Right. Well, as I said, in principle, if you have one level sensor, flow sensor, rain gauge, this is enough to get started. You can log on and you can see what this is showing at any time. Or it could be a pump reporting how much it's pumping. And let's say it's a flow measurement. Then we could also perform an INI analysis based on this only, or look at the pump performance. But of course, the more data you have, the more interesting it gets. But there's no limit to how much you need to have available to be able to have access to this product. It can really be how much or how little is relevant to you in your system.
Great. Thanks for taking the time to answer that. Another question that we got in preparation for the webinar is, how do you choose whether a rule-based or optimizing algorithm based on control is better? How do you choose between those?
Right. Well, this is a difficult one. It's individual for every system. As a rule of thumb, if it's a very small system or small catchment, you can get far with a rule-based control. And this is also important if you want to feel safe with the control, that it's something you understand at all time what the rules are. The model predictive control can be implemented in all types of systems, but really the best thing to do is to share with us information about your system, and then we can very quickly do an analysis and see whether you'll benefit from adding the forecast element, also based on the size of your catchment, or whether a simple rule-based control will be sufficient for your needs.
Great. And just one more question that was emailed in prior was, it seems, if I don't have a CSO, how could this technology potentially benefit for me? Is that something you could take, Mark?
Yeah, I'll address that. So, obviously here in the United States, relative to maybe, the systems over in Europe, we do have a lot of CSO communities, but we have many, many communities that are not, it's more separated sewers. But certainly, whether it's rule-based or whether it is model predictive and incorporating, rainfall forecasts and things of that nature, better management of flows within just strictly the sanitary sewer system will be a result of implementing these types of solutions. And Kirsten also mentioned the inflow forecast, which is a very valuable tool at the ultimate treatment facility or water reclamation facility, where all this water is ultimately ending up. So, these tools will enable a reduction in SSO events, not just CSOs. Will allow you to better manage flows at the treatment facility and allow you to predict when you will see increased flows due to wet weather events, which you'll see strictly through INI, even if you don't have a combined system. And then just in addition, the overall insight, as Kirsten mentioned, into having a better view into what's happening out in your system. All those types of benefits are certainly still there, even if you are not a CSO community.
Great. Well, again, I want to thank everyone that took a little bit of time out of their day to go watch this on-demand event. It was really insightful with what the experience that Kirsten brought and the expertise that Mark Drake brought to the table. And of course, I want to thank both of our panelists for preparing the presentation and sharing all of that knowledge with all of you here today. So if you have any questions, again, Mark Drake and Martin Tesper is listed there on the screen. You could email them directly and start a conversation about how this particular digitalization technology may be able to support you and your organization. So again, thank you all, and I wish everyone a wonderful day.